Hi guys, welcome to Maths with OG. In this section, we'll be looking at approximations. Approximations involving significant figures, number of decimal places, and other things like approximate to the nearest tens, approximate to the nearest hundred, as the case may be. Now, before we define what decimal places and significant figures mean, let's just throw a little light on what approximation entails. Whenever you are asked to approximate, you are asked to round off to a value that is very close to a particular number. So the basic thing you need to know under approximation firstly is that your digit numbers ranging from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, when you are asked to approximate, half of it round off to 0 and half of it round off to 1. So if I divide it into 2, whenever you have a 0, 1, 2, 3, 4, this round down to 0. Whenever you have a 5, 6, 7, 8, 9, this round up to 1. And if you understand the basics of approximation, there will be no need going through the stress of saying it round off to 1 or it round off to 0. So I'll give an example on what I mean. Now you are given a number like this. Let's say you are given a number, let me formulate a number 1258, for example. You are asked to round off to the nearest thousand. You are asked to round off to the nearest thousand. Ideally, what you simply do is to check this is your unit term, this is your tens, this is your hundred, and this is your thousand. So if this is your thousand, you move to the right and check the next number. The next number, will it round down to 0 or will it round up to 1? Obviously, the next number is 2. So you check 2 here will round down to 0. So this guy automatically becomes 0. And if this guy becomes 0, my answer will simply be 1000. You don't throw the rest numbers away because you can't round this to the nearest thousand and your answer will just be 1. It means that 1258 is closer to 1000 than it is closer to 2000. And it is obvious 258 is closer to 0 than it is closer to 1000. So I can say everything here round down to 0. I can bring another question again. You have 5764. Round this number or approximate this number to the nearest thousand. You simply ask yourself 5764, is it closer to 6000 or closer to 5000? Without counting unit tens, hundred, and thousand, it's obvious that this guy is closer to 6000 than it's closer to 5000. Automatically, the answer here becomes 6000. They can also ask you, round up this guy to the nearest hundred. To the nearest hundred means that you are dealing with 764. So if you check, the next guy here, 6, will round up to 1, so your answer should be 800. Your answer here should be 800. But without going through that stress of checking, will 6 go to 1 or 0, you can just ask yourself, 764, is it closer to 700 or is it closer to 800? Because obviously it is between 700 and 800. It is closer to 800. So therefore, rounding off this guy to the nearest hundred should give me 5800. So the ideal way of solving it is saying this is unit, this is tens, and this is hundred. So check the next number, round up to 1 or round down to 0. This will round up to 1. So 1 plus 7 becomes 8. So therefore, I'll be having a 5800. But I just told you that in order not to go through that stress, just check 764 is between 700 and 800. Is it closer to 700 or 800? Obviously, it's closer to 800. Because if you do 800 minus 764, you'll be getting a smaller value than if you do 764 minus 700. So obviously 764 is closer to 800 than it is closer to 700. So this automatically becomes 5800. So that's the approach you use when you have to round up to the nearest 100, 1000, million. You can be asked this question, round up 400 to the nearest 1000. Now you are in between two numbers. Either you are going to 0 or you are going to 1000. You ask yourself, is 400 is it closer to 1000 or is it closer to 0? It's obviously closer to 0 because 400 minus 0 is 400, but 1000 minus 400 is 600. So it is closer to 0 than 1000. So this guy to the nearest 1000 is simply 0. So that's how you work on nearest hundred, nearest thousand. We'll still come to that. Now let's focus on decimal places and significant figures. Decimal places. What are decimal places? To find the number of decimal places, simply count the number of figures after the decimal point. Simply count the number of figures after the decimal point. So I have a number like this, 5.6432. How many decimal places is this? 1, 2, 3, 4. So this is obviously 4 decimal places. So if you are asked to approximate this guy to 2 decimal places, it means that you should have only 2 numbers after the decimal point. If you are asked to approximate this guy to 20 decimal places, it means you should have 20 numbers after the decimal point. And that can be gotten by adding 000 till you have up to 20 numbers after a decimal point. So that's for decimal point. That's for decimal point. Now that we know what decimal point is, let's answer this question. Write 871.7542. 871.7542 correct to the nearest whole number, 1 decimal place, 2 decimal place, and nearest thousand. By now, you should know that we pronounce whole number part as 800, 700 as the case may be, but the decimal part, we pronounce it as 7542. We don't call this 7,542 ideally. So 871.7542 to the nearest whole number. It means they are asking us this number here is obviously between 871 and 872. I'm explaining how you can get your answer without checking will it go to 1 or go to 0. This number is obviously between 871 and 872. Now you ask yourself, is this guy closer to 872 or is closer to 871? It is obviously closer to 872. And how do you know which of the number is closer to? If you do 872 minus this, the answer you will get will be smaller than if you do this guy minus 871, because this guy is just in between the two, but it's obviously closer to 872. So the answer should be 872. Now let's use the ideal way to solve it. 871.7542 nearest whole number. So this is where my whole number stops, 871. So we look for the next number after the whole number, and that number is 7. Note, we have no business with the number after the next number. Note, we have no business with the number after the next number. So we have no business with 5. You cannot say 5 will round up to 1. This will now be 8. Then from there you go to this. No. You look for the next number. That's what you do. Now the next number is 7. Will 7 go to 1 or go to 0? This we obviously go to 1, like we stated. So 1 plus this 1 will give us 2. So the answer to the question for nearest whole number should be 872. So that is the answer to the question. So that's how you solve. So what I was explaining earlier is that supposing you are having 871.4542 nearest whole number, the next number here is 4. Will 4 go to 1 or 0? 4 will go to 0. So your answer should be 871. You don't say because here is 5, you say 5 will go to 1, automatically this guy becomes 5. So this guy that is now 5 will go to 1, so this guy becomes 2. It is very wrong, because merely checking at this, you will observe that 871.4542 is closer to 871 than it is closer to 872. It is closer to 871 than it is closer to 872. All right, now the next one, 1 decimal place. 1 decimal place. Let's approximate this guy to 1 decimal place. So the 1 decimal place here is 7. So what do? We look at the next number after the 1 decimal place, and the next number is 5. So you ask yourself, will 5 go to 1 or go to 0? 5 will go to 1. So 1 plus 7 becomes 8. So my answer here should be 871.8. So that's the answer to the B part. Now the C part, 2 decimal places. You check first decimal place, second decimal place. So you look at the next after the second decimal place. Will 4 go to 1 or 0? 4 will go to 0. So 0 plus 5 is 5. So to 2 decimal places, this should be 871.75. So that is the answer. The next is nearest thousands with a TH. Nearest thousands with a TH. Now remember, when we are dealing with numbers, let's say I have this number 111.1111. This guy here is the unit. This guy here is the tens. This guy here is 100. That's why we call this one just 1. This guy is called what? 10. And this guy here is 100. So that's the place values of this guy. Then after the decimal point, this guy here is called tenths with a th. This guy here is called hundredths with a th. This guy here is called thousandths with a th. This guy here is called 10,000 with a th. So another way you can be asked approximate to one decimal place is asking you approximate to the nearest tenths. Approximate to 2 decimal place, you can be asked to approximate to the nearest hundredths. Approximate to 3 decimal place, you can be asked to approximate to the nearest thousandths. Approximate to 4 decimal place, you can be asked to approximate to the nearest 10,000ths, as the case may be. So we asked to approximate to the nearest thousandths, and thousandths is simply 3 decimal place. So we check 3 decimal place. This is 1, 2, 3. So we look at the number after the 3rd decimal place. So will it round up to 1 or round down to 0? Obviously round down to 0. So my answer will be 871.754. That is the answer. As easy as that. If you are asked to approximate to a 4th decimal place, this is your answer. It does not change. Approximate to 5 decimal place does not actually make sense. But if you ask to leave your answer in 5 place of decimal, you simply add 0. Leave your answer in 6 place of decimal, add another 0, as the case may be. So that's that for decimal places. It does not get bigger than that. It does not get bigger than that. That is the whole idea about decimal places. Now let's move on to significant figures. Significant figures, for you to just understand how to know your first significant figure, and you are good to go. Note, the first significant figure is the first non-zero digit from the left. So when you are reading a number, the very first non-zero digit that you read is the first significant figure. So any zeros you are seeing before the first non-zero digit, they are insignificant. That means they are not significant. But after the first non-zero digit, any zero you see after that automatically becomes significant when representing significant figures. So let me explain by dropping some numbers on the board. So I believe I can wipe this part. Now I have a number like this, a typical number 464. This guy here is the first significant figure, this is the second significant figure, and this is the third significant figure. I have another number 400. This guy here is the first significant figure, this guy here is the second significant figure, and this guy here is the third significant figure. We can't say these two guys are insignificant, because if I take them off, the number here automatically becomes 4, no longer 400. So it means that these two zeros play a very important role in making sure that this number is 400. I have another number 004. These are zeros, so they are not significant. So 4 automatically becomes the first significant figure and the only significant figure. So without this 0, this guy remains 4. With this 0, this guy is still 4. Now let's add decimal points. I have a number like this, 404.00212. This guy here is the first significant figure, very significant. This guy here, second significant figure. Without this 0 here, this guy automatically becomes a 44, which is different from the number. So therefore, that 0 there is significant. 4 here is significant. 0 here is significant, because without this 0, this number changed to 404.0212, which is different from 404.00212. This guy is significant, this is significant, this is significant, and this is also significant. Let me put another number on the board. 404.21200. This is significant, 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 significant. They are all significant because taking away one of these numbers will alter the number generally. But you see these two last 0 here, they are insignificant. So when 0 becomes the last number after the decimal point, it becomes insignificant. When 0 is the first number in the whole number part, it also becomes insignificant. But imagine I add another number here, 5. Automatically, these two zeros become significant because taking away one of these zero automatically change the number. But if I add another zero here, this zero here is insignificant. So that's how you know significant numbers and non-significant numbers. So once you've gotten the first significant number, just know the next is the second, the next is the third, the next is the fourth, as the case may be. Now, if you look at this question, they say write this to one significant, two significant, three significant figure. First zero is insignificant. Second zero is significant, meaning that it gives this number a meaning, but it's insignificant. In the terms that if you are asked to approximate to one significant figure, you cannot say 0.0. Not possible. But this zero is meaningful in this number, meaning that you cannot take away this zero. Then this zero insignificant. This zero is insignificant. So this guy is the first non-zero digit. So this guy automatically becomes the first significant figure. Like I explained, this is the first significant figures, but these zeros are important in your answers, but they are not significant. This zero here is a significant figure and it is important in your answer. So this is the first significant figure, second significant figure, third significant figure, fourth significant figure. If I add the zero after this 5, that zero becomes insignificant. It does not have any row that is playing, meaning I can take it off. If I add the zero behind this guy, insignificant, I can take it off. It does not have any row that is playing. But these guys, they have row that they are playing. But since they are zeros and there's no non-zero number before them, we consider them to be insignificant. Now, if I'm to write this guy in one significant figure, like we just said, 7 automatically becomes the first significant figure. So we approximate the next guy, which is 6. 6, will it round up to 1 or round down to 0? It will round up to 1. So that 1 plus 7 automatically becomes 8. So my answer will be 0.0008. And like we did for 100, when we approximate to the nearest 100, thousands, and the rest, every other number will turn to 0. But in this case, changing every other number to 0 will not change anything. That means when I'm done with 8, I should change it to 0, 0, 0. So imagine changing this guy to 0, 0, 0. Does not change anything because 0.0008 is the same thing as 0.0008000. These guys are meaningless, so I can clean them off. So my answer will be 0.0008. Next question, write down this guy to two significant figure. So this is the first significant figure, second significant figure. So we check the third guy. Will 0 go to 1 or 0? This automatically goes to 0. Now 0 plus 6 is still 6. So my answer will be 0.0076. There's no need changing the other two guys to 0 because putting 0 and 0 here does not make any sense, ideally. Now, three significant figure. First significant, second significant, third significant. 5, will it go to 1 or 0? 1. 1 plus 0 is 1. So my answer will be 0.000761. So that's the answer to the question. That's how you approximate to significant figures and decimal places. Now, let's use that idea to answer the following 5 questions. So ideally, when you are solving questions in, I don't think they will test your knowledge on this in physics, but in maths, after solving, you will see something like this. Leave your answer to the nearest cm. Leave your answer to the nearest naira, to the nearest thousand, nearest milliliters, as the case may be. Sometimes you might see questions like this in physics. That is when they are testing your knowledge on approximating the final answer. So how do you go about this? Very first question. You are asked 106.925 meters to the nearest centimeters. 106.925 meters to the nearest cm simply means approximate or change this number to centimeters and leave your answer in whole number in centimeters. I repeat, change this guy to centimeters and leave your answer in whole numbers in centimeters. Now, for those of you that are still confused about changing from meters to centimeters, meters to milliliters, as the case may be, I will advise you try to understand prefix in terms of centi, milli, as the case may be. Your centi in science is simply 10 raised to the power of minus 2. Your centi is simply 10 raised to the power of minus 2. So therefore, your centimeters should be equal to 10 raised to the power of minus 2 meters, because meters is actually the unit. Centi is just a prefix. So your centimeters is simply meters over 100. That's why you are told whenever you are changing, whenever you see a centimeters and you want to change to meters, you simply divide by 100. I think some of you still remember that. Whenever I see a centimeter, you want to change to meter, I simply divide by 100. That's why 100 cm is equal to what? 1 meter. Because 100 cm changing to meter, this guy automatically becomes 1 over 100. 100 over 100 automatically becomes 1. Then when you are converting from meters to centimeters, you simply multiply by 100. So that's one of the basics of what we are doing. So I believe you can check that out yourself. So changing 106.925 meters to centimeters is simply 106.925 multiplied by 100. And since I'm dealing with tens and powers of 10, I simply move my decimal point to the right the number of times I have zeros. I have 2 zeros here, so I move it to the right twice. 1, 2. So this will give us 10692.5 centimeters. So this is 10692.5 centimeters. What does that mean? 106.925 meters is equal to 10692.5 centimeters. Now we have to change this guy to the nearest whole number in centimeters. So in whole numbers, the whole numbers I have here is 10692. Now approximate the next guy after the whole number, that is 5. 5 does not round down to 0, rather it round up to 1. So add that 1 to this 2. So this will give us 10693 centimeters. So the answer here is 10693 centimeters. That's the answer to question number 1. Change to centimeters, approximate to the nearest whole number. This one is straightforward. 608.41 to the nearest naira. 608.41 to the nearest naira. This is between 608 and 609. Question is it closer to 608 or 609? Obviously closer to 608. And you can check after this whole number, the next number is 4. Does 4 go to 1 or 0? It goes to 0. So this automatically gives us what? 608 naira. Next guy, 4,995 kilometers to the nearest thousand. So we are still working in kilometers, but we have to change this guy to the nearest thousand. 4995 is between 4,000 and 5,000. Is it closer to 4,000 or 5,000? Obviously closer to 5,000. So the answer should be 5,000 kilometers. Or you check units, tens, hundred, thousand. The next number after 1,000 is 9. Does 9 go to 1 or 0? It goes to 1. 1 plus 4 is 5. So this will give us 5,000 kilometers. Next is 9.0599 liters to the nearest milliliters. So we change to milliliters and leave our answer in the nearest whole number in milliliters. Now what is milli? Milli, like centi, is a prefix and is equal to 10 raised to the power of minus 3. So that's why 1,000 millimeters equals to 1 meters. 1,000 millimeters equals to 1 meters. Similarly, 1,000 milliliters equal to 1 liter. So when you are changing from millimeters to meters, you divide by 1,000. But when you are changing from liters to milliliters, you multiply by 1,000. So change this guy to milliliters will simply be 9.0599 multiplied by 1,000. Now this is a power of 10. 3 zeros, you move 1, 2, 3. So this will give us 9059.9 milliliters. Now we have to approximate this guy to the nearest whole numbers in milliliters. So we have 9059 as the whole number. Look at the next number after the whole number. That's 5. 5 will round up to 1. Add 1 to 9059. So this will give us 9060, because 1 plus 9 is 10. Put down 0, carry 1. 1 plus 5 is 6. So my answer here will be 9060 milliliters. Then lastly, you have 89.506 naira to the nearest kobo. Change to kobo and leave your answer to the nearest whole number in kobo. Now how do you change from naira to kobo? This is not, mathematics does not decide the relationship between naira and kobo. the country actually decided the relationship between naira and kobo, and the relationship is 100 kobo is equal to 1 naira. 100 kobo is equal to 1 naira. So when you are changing from kobo to naira, you divide by 100. From naira to kobo, you multiply by 100. So from this guy, change this guy to kobo is simply 89.506 multiplied by 100. Now you move this guy twice to the right, 1, 2. So that will give us 8950.6 kobo. Now 8950.6 kobo, the whole number part is 8950. The fractional part is 6. Now 6, will it round up to 1 or 0? To round up to 1. So my answer will be 8951. So this will give us 8951 kobo. So that is the answer. That is how you approximate in decimal places, significant figures, nearest tens, nearest hundred, nearest thousands, as the case may be. If there's any part that was not clear to you, don't hesitate to use the comment section. I'm always there to reply your messages. Now, if there's any error in the calculation, also feel free to leave it in the comment section. I'll go through them. Thanks for watching. In our next video, we'll move on to fractions and some operations in fractions, or rather how fractions exist or how you work with fractions, because I noticed that some people find it difficult working with fractions. So don't hesitate to use the subscribe button, which will make me happy, and also use that share button to share to friends you know we also need this video. Thanks for watching once more, and see you guys in my next video.